We good? Cool.
Hi, welcome to me and Hunter's 20% project presentation. So we decided we wanted to do our 20% project on what would actually happen if you took scenes from different superhero movies and applied science to them. So we decided that we wanted to do this because who doesn't like Marvel? And like Marvel's really popular nowadays, so why not take scenes from different Marvel movies and then expose Marvel for uh, being bad at science? And so we ended up choosing two different movies, Deadpool and Ant-Man. So Deadpool, he can change his size. No, that's Ant-Man. he can um, he can rapidly heal himself very fast, and Ant-Man can change his size. And now Hunter's going to talk about Deadpool.
Yeah, so as Cooper stated, I'm doing Deadpool and his relatively well-known power of rapid cellular regeneration. Um, yeah, he's stated as having an accelerated healing factor by Marvel specifically, and this enables him to survive otherwise fatal injuries. While researching him, I actually came up with a paragraph that talked about specifically how he's able to regenerate his neurons or brain cells. But I did discover a actual fatal flaw in this premise, and that is his memories. So memories exist as a sequence of electrical and chemical signals. So if you can imagine, you have a neuron, or which is a brain, same thing as a brain cell. You have a dendrite on one end of the neuron and an axon on the other end. Memories exist as an electrical signal going from the dendrite to the axon of a single neuron, and then they are transferred into chemical signals that move across the synapse to the next neuron, transferred back into an electrical signal. Chemical, electrical, same sequence. So short-term memories are stored in the electrical chemical signal sequence. Same for long-term memories when their short-term memories are transmitted into long-term memories through the hippocampus. So generally they're stored as electrical and chemical signals. And so while Deadpool has been explicitly stated as being able to regrow his neurons, he would not be able to regain any of his memories because in long term and short term, both cases, they're never stored as tangible things like neurons. They're never stored in the neuron or as a neuron. They're just electrical and chemical signals. So yeah, once he was killed, and once in the movie, or in a comic book, I forget which one, he is recorded as growing his whole body back from a single blood cell. And while he could do this and regain his neurons, he won't be able to regain any memories as they're not physical. They're not stored as physical objects.
And now Ant-Man. So uh, I was pretty when I started researching Ant-Man, I was pretty sure that two things might happen. One, because in the movie he shrinks to a subatomic size. I was pretty sure that that might that I was pretty sure that that might create the possibility of him becoming a black hole. And then also when he's subatomic in the movie, depending on how long, I was pretty sure that depending on how long he's subatomic, um, he would pass out or die from lack of oxygen. Um, so first, black hole. A black hole is a piece of matter with that is very, very dense, and it's so dense that it has a really strong field of gravity, and the gravity is so strong that it attracts, it pulls everything into it, even light particles, which are photons. And the minimum density of a black hole is two times, using scientific notation, 2 × 10⁻¹9 kilograms per meters cubed. That's very dense. It's incomprehensibly dense. Um, so then I took the average human body and applied math to it. So the average human body weighs 70 kilograms and has a volume of 95 liters. Then an atomic particle. The volume of an electron is, also using scientific notation, 10 times 10 to the negative 30th meters cubed. Um, a meter cubed is equal to about is equal to 0.001 liters. But so in the movie, uh, Ant-Man, he shrinks to subatomic levels. He shrinks so small that it's past electrons. It's into string theory, which is just a theory. So I had to take. So I couldn't. So there's no like measurements for how. For the volume of a string or anything like that, so I took the smallest subatomic particle that's been confirmed exists, which is a quark, and a quark is less than 1/1000th the size of an electron. For simplicity's sake, uh, I used the size of a quark as being 1/1000th the size of an electron, so 10 times 10 to the negative 33rd meters cubed. So then you use math. The mathematical formula for to find density is mass over volume. So 70 divided by 10 times 10 to the negative 33rd is equal to 7 times 10 to the 32nd kilograms per meters cubed. That's very, very dense. It's far denser than uh, the minimum requirement to become a black hole. So he would become a very, very large black hole that would suck everything on Earth into it. So everyone on Earth would die, and then it would be denser than the sun. So if for some reason the entire solar system didn't get sucked into it, we would nothing would rotate around the sun anymore. Everything would rotate around what used to be Earth, and that would be very fun. And then lack of oxygen. So in the movie, he's subatomic and too small to inhale oxygen for about 100 seconds. So the effects of no oxygen is 30 to 180 seconds. You lose consciousness, and at about 60 seconds, brain cells start dying. This causes brain damage, but this is brain damage that can be repaired. It's not permanent brain damage. That happens at between 3 to 5 minutes without oxygen. So he might pass out, and he would suffer some brain damage. And now Hunter will talk.
So before we really even started to definitively come up with our topic, when considering this topic, we knew that it would be really 100% research and there'd be no experimentation because it's really impossible to replicate a lot of the events in this movie accurately. So we knew it would be a lot of research, but that didn't really affect us much because we did a good job in thinking about this beforehand and thinking, are we okay with this? And yeah, and that's why we did it. A thing we definitely could have done better, though, is research more powers. On that note, we did start out with 4, 2 each, but my second one took me about 30 minutes of semi-complicated math, and I had figured it all out. And Cooper's,
Mine, I was researching for months, trying to find any information on friction, fission, and the tensile strength of human bones and the human body, and impact from running, because I was doing the Flash, and that didn't work out at all.
yeah, I mean, that caused us, like, Cooper, unsurprisingly, couldn't find a lot of information on the internet about the effect of nuclear fission on human legs. So that caused us to waste a lot of time, probably weeks at least, on just researching that. Eventually, Cooper just had to give up because there wasn't anything nothing to base it off of, and we high school students can't really do that without any information on to back us up on the internet. So what could have prevented that is a pre-research evaluation of topic difficulties. So just what that means is pretty much evaluate before we start researching how difficult, think about each topic and think, can we do this, and can we reasonably do this in a given amount of time? That would have saved us weeks and probably allowed us to research more superpowers. So my connection to biology was pretty clearly the neurological functions and communications that I talked about.
And my connection to biology is the effect of no oxygen on the brain. Thank you for coming to our 20% project. Does anyone have any questions? You in the back. Kind of. Kind of. He asked, was it fun? And my response is kind of. What was Hunter?
I mean, I thought it was. Yeah. It was interesting.
It was kind of cool once I actually had information, but it was really frustrating for me when I was going for weeks trying to find anything and not finding anything about my first superhero.
I liked it because I like biology. It was mostly just math and biology, and I liked both of those subjects, so I definitely enjoyed it.
Thank you. Bye.
Take a couple minutes while we switch presenters and provide some feedback. Make sure you put your name and the presenter's name again.
$3895。咱们可以站这边。我坐那边。
你先讲一下，要先开头了。
他们要那什么，我先讲。
我知道，这样。
我讲完以后你讲。
你不是要说我们的 go 吗？你说完 go 之后，然后我再解释的 video。
然后我再说 video。
对，然后说 video。这样是这样的，就是你觉得你说够了，就是你要适当的停下来，你把麦克给我，然后我再说，然后我觉得我说够了，停下来给你，反正每页我们都知道。我的妈呀，像那个。
你不要说这个词，对他们底下会误解。
我只是觉得有点像公开处刑。妈，他说的可想来了。应该还没有吧？是要等老师来。
Yes, so we are waiting for Dr. Crothers to come back.
You gotta set up this though.
Thank you so much.
Oh, it's on?
It's on?
Is it live stream?
Oh, it's a live stream, okay.
They can all see your
No,
beautiful
we can't do
face.
Okay, so we'll start. So, good evening, guys. My name is Alan.
And my name is Marie.
Today we're thrilled to share our 20% project with you guys. As some of you might previously known, we're doing our project on ASMR, aka Autonomous Sensory Meridian Response. Our goal for the presentation is to research the reason behind this phenomenon and eventually make it into a more effective utility that helps the relaxation of people.
So the reason why for us to make this research is because I believe many of you didn't know what ASMR is, which we are gonna explain to you later. ASMR is a relatively new concept, which is just came out on the internet at the year of 2015. So both of us love to listen to these kind of videos. It makes us feel relaxed. So we would really like to learn more about it and share this experience to all you guys.
Right. So in order to start our discussion, we will start off with a video composed of 3 ASMR videos, and we asserted certain parts of these 3 videos into a shorter one. Yeah. Oh, it's stopped. So a quick question for you guys. Did you feel anything while listening to the sound? Yeah, it's okay to say no, because usually we listen to these kind of videos with headphones, and in order to capture the most sensitive sounds, and these sounds are relatively low pitched, so we really want to capture each of the sound.
So in this video, we pick 3 ASM artists. This is a term which define people who are doing these kind of videos. And as you guys might know, me and Alan are the second and third part. And the first ASM artist is one of our favorite on YouTube. So now we would like to dive into our topic. So what is ASMR? ASMR is also known as Autonomous Sensory Meridian Response. It is a perceptual stimuli which includes certain kinds of ASMR triggers which brings people relaxing, tingling sensations.
These sensations are often defined as flow state, like this little person right here. And it's also defined as an electrostatic feeling that can bring you relaxation.
So these are 3 comments we find online. It is a website called ASMR University. This includes a lot of people who are interested in listening to ASMR. So we found 3 comments about what people feel when they're listening to it. So as Katie said, when I experience ASMR, I get tingles throughout my scalp and sometimes at the back of my neck. So you will usually feel from your scalp and your neck, it's like a warm and fuzzy feeling.
And as Promise said, when I experience ASMR, I get the same tingles and waves over my body that one would experience when getting their hair brushed, or when using one of the little contraptions that kind of scratches your head. I have no idea of what it is called.
So I believe this is the same feeling that most of you are feeling right now, but don't worry, we're gonna talk more about it. So as Peggy said, ASMR feels like a pleasant sensation, and she also feels this feeling on her scalp, back, arms, and legs, and they are super relaxing.
So ASMR triggers include 4 kinds of triggers. These triggers are always gentle, steady, and repetitive with low volume.
So there are 2 kinds of ASMR triggers. One is called intentionally triggers, and one is called unintentionally triggers. So for intentionally triggers, people are making that sound. So that is what ASMR artists usually do in that video. So as you guys may see in this picture, there are several examples of the intentionally sounds, such as eating a biscuit or tapping something, like tapping a bio book. Um, or like this ear humidifier. So when we are creating ASMR videos, we tend to use a special kind of microphone, as drawn there. It is like an ear-shaped microphone, so it can make the sounds as more realistic as it can be. And they are called the binaural microphones.
And to add on what she said, unintentional triggers are something that the sounds that we encounter in daily basis. And unintentional triggers can include like getting a haircut in a barber or even being treated at a clinic. And intentional triggers, they are like the ASMR artists want to make these sounds in order to make the people feel that certain sensations. So they are purposeful, and like unintentional are like unintentionally.
So now we're gonna talk about the mechanism, like how will you feel ASMR? So among all the people in the world, there are two kinds of population. One is called ASMR capable individuals, and others are called ASMR non-capable individuals. And these are related to the connectivity between certain parts in their brain.
There are three parts in the brain that are related in this process: the occipital lobe, temporal lobe, and frontal lobe. Each serve different functions in this process.
So the occipital lobe is responsible for vision. So when you are watching these kind of videos, you tend to look at the movement the ASMR artist is doing. And the temporal lobe is responsible for listening. So of course you are listening to the video, so you need to listen to the sounds. And the frontal lobe is responsible for focusing on the video itself and feeling the sensations.
So in order to be more specific, we want to go into the neuroanatomy field of biology. So there are four kinds of chemical involved in the process: serotonin, endorphin, dopamine, and oxytocin. Serotonin basically it encourages your mood to listen to ASMR videos, and it induces sleepiness during the process.
So the second kind of chemical is called endorphins. It is responsible for people to release certain kind of euphoria and also increases people's sleepiness during watching the video. And dopamine is responsible for people's desire and attention when they are watching the video.
So the last one, oxytocin, it basically reduces the stress of the people, and it creates more sensitivity to the endorphin receptors.
Talk to you. So when you are feeling ASMR, different parts of the brain are working. For the purple parts, you can see they are responsible for concentration, which means you're concentrating to the video, and touch, which is responsible for your feeling, and of course the hearing and vision areas. So when you are feeling ASMR, these parts are being activated together, so you can feel that kind of sensations all over your body.
So for the blue part, these are different glands that produces the chemical that we just talked about. For the pituitary gland, the serotonin and oxytocin are produced right here. And for the pineal gland, it produces the endorphins.
So since we are discovering this phenomenon and which involves people listening to them, we did a survey during our 20% research. So in our survey, we tend to find out any possible variables that influences people's capability to experience ASMR.
And actually, Marie made this video, and the video is like about 24 minutes, and each trigger is about 30 to 40 seconds. And we want to observe different influences of the factors that we concerned in the survey, how it impacts the experience of ASMR. Oh, okay.
So based on our data, we get these kind of graphs. The variables we're concerning about is the participants' gender and their age range, and also their current health condition, and of course, how many amount of sleep they have each night.
And we will take a look at the data later. And we also concerned whether the participants have insomnia and the things they do before sleeping. And most of the participants don't have insomnia, and 20% of participants had insomnia. And these are the list of the things that people do before sleeping, such as homework, video games, work, shower, reading, YouTube, and other things.
So here are some data results. So based on our data, among all the participants, there are more teenagers than adults, and there are more male participants than female participants.
And we concluded that most participants have healthy lifestyles because the things that they do before sleeping are relaxing and they're getting enough amount of sleeps. Most of them, I mean, like around 5 and 6 hours. Some people do get 5 and 6 hours of sleep, which is not really good. Oh, and the reason why they're not getting enough sleeping is because our participants are mostly students who have a lot of work. So, a lot of stress.
We also found that most participants tend to do healthy lifestyles and they are using really healthy ways to relax themselves before sleep. So we concluded that when people are having healthy lifestyles, they tend to have ASMR capability. And as we're going to talk about later, all the participants in this survey feel ASMR sensations.
So these are the 24 triggers we included in the video. And most of them believe that this group focusing on your ear gave them the most ASMR sensation and the most tingling sensations. A lot of them like the ear massage, like massaging on the microphone, but it's not actually massaging on your ear, but you still feel that same sensation. And there are also hand movement, ear picking, ear brushing. It's basically doing things that nearby your ear that gives you relaxation.
And we found two interesting facts during our research. One of them is the place where people feel tingles. So one particular participant tell us that he feels tingles on his right side, which is usually not common because most of us feel tingles on our scalp.
Yeah, around the neck and the scalp region. And there is a possibility of misophonia during of our participants because some participants described the tingles as a disgusting feeling and that hurt their soul and something like that. It's probably because of misophonia. And we'll explain misophonia later in our discussion.
So here are some really interesting facts that serves as ASMR extensions. So the first one is ASMR can be used as a treatment to several different kinds of disease, such as insomnia, chronic pain, or depression.
So here we come back again to misophonia. And misophonia is basically the participants have abnormal connections between the structures of the brain we just talked about. And their symptom is that they detest the stimulus that we provide in the videos. And they just they don't like it. They really don't like it. Especially the mouth sounds, the lip smacking sounds like, no, they don't like that. And 50% of the misophonia individuals, population, experience ASMR at the same time. It's just they don't like it.
The third interesting fact is about some people's immunity to sounds. So suggest like you are listening to a ASMR video and you really love a sound that makes you trigger and feel relaxing, and you start to listen to it the whole day, and you listen to it again and again, and after 2 days, you suddenly feel, oh, I cannot feel any tingles again. So this is kind of a situation where you are immune to this kind of sound. And what is more interesting is if you stop listening to it for a long period of time, you'll regain that tingling sensations. So we need to do more research on that because we cannot fully explain it.
And another interesting fact is the interpersonal connections. ASMR is also known as a good relationship between individual and the interaction between two individuals. Like ASMR artists show amiability in their videos in order to increase their connection with the audience. And a scientific research has shown that a closer relationship can induce extra endorphins that can make you feel good and feel relaxed. These relationships include a mother and a baby, and maybe two good friends, and maybe a romantic relationship. So these relationships can always bring people good feelings, and we will do more research on that too.
So the last interesting fact is about ASMR scenario, which means in order to create a successful ASMR video, ASMR artists tend to use warm colors organized environment. Also, their distance between themselves and the microphone and the camera is also important. So these are all really unsure stuff. So we are keep doing research on that in order to understand it more.
So yeah, these factors influence people's ability to experience ASMR. And here are our reflections or further expectations. Of course, we need to do more research on why people are experiencing ASMR and of the interesting facts that we just talked about. And we expect more experts to get into this field and give us more scientific phenomena. I mean, like we high school students, of course, we cannot do research and experiments on some stuffs. So we need other people to do it for us.
And also, we want to ask people to understand this phenomena more and provide more understanding to it, because ASMR is a really new concept which comes out into people's view like a few years ago. So we want to use our research to let more people understand it and enjoy it, because currently in society there are many stereotypes on ASMR. So we really love to reduce that.
And we also would love to create an ASMR relaxation club. This club is intended to like give other people relaxation, because we really concerned about, no, not concerned, we really care about the physical and emotional health of WA community. So when we can do more research and we can make it into a more effective utility that helps relaxing people, I mean, we can help a lot of people out there. There are so many people stressing about their schoolwork and stuff. So, I mean, if we can create a club and so many people can relax themselves and have a good time, that would be great. So yeah, that's the end of our presentation. Any questions? Oh.
So where do we see the video that you created and sent out for the?
Oh, we have different YouTube channels.
Oh, you guys both have your own.
Yeah.
Yeah.
Uh-huh. Yeah, she has like 40 subscribers and I have only 10. I just started. Yeah. Yeah.
Yeah, and actually, if you can just search the term ASMR on YouTube, you can see several different videos created by many different people.
So many of them.
Yeah, so many.
And any other questions?
Did you come across anything in your research connecting it to other disciplines like meditation or philosophy or anything like that?
I mean, like meditation can always reduce the heartbeat. Like it will calm you down. Like you won't think about so much other than the subject that you're meditating on. So I think it's certainly related to ASMR and relaxations.
And actually, meditation it's a kind of ASMR. I had seen once. It's about an ASMR artist just standing there and tell you, breathe with me, relax, and they are really calming background music also. And that video lasts for 1 hour, and
Yeah.
it's really great.
It's one type. And other questions?
So thank you so much for listening to our research, and we hope you guys can use ASMR as a relaxing tool for your future life. Thank you.
Thank you.
Okay, so I just click that. Oh,
Right here.
does it
Yeah, that
this
one.
way?
No, no, the other one.
Oh, both. I'm like shaking. It's not good. Okay.
Audio.
Yes, please. Oh,
Now
hold
audio.
on. Yeah. Can I just put it on present first? Oh, oops, that doesn't work. Jesus. Okay. Oh. Where? Oh, sorry.
Okay, now go underneath that and click
Oh.
headphones. And then your volume will go up and down.
All right, okay, got it. Thank you. All right, so hi, I'm Selena Shen, and for my passion project, I decided to choose the topic anxiety. I chose this topic because it's really personal to me and because I realized that it's something everyone can relate to, at least somewhat, especially people that are my age, because we are always anxious about something. If it's something that's not academic related, it's something that's socially related. So I wanted to research how exactly anxiety worked and the best ways to overcome it. So starting from the basics, anxiety itself is a feeling of worry or fear, while an anxiety disorder is constant worry or fear that begins to interfere with daily activities. The main types of anxiety are PTSD, or post-traumatic stress disorder, OCD, or obsessive compulsive disorder, specific phobias, panic disorders, social anxiety disorders, and the most common being a generalized anxiety disorder. The symptoms of anxiety are constant panic, sleep problems, nausea, dizziness, and tense muscles. Anxiety can be caused by a variety of things, such as stress, genetics, and other mental problems. So you guys are probably wondering, how exactly does anxiety work? So starting with the foundation, there are two main systems that are involved with anxiety: the sympathetic nervous system and the parasympathetic nervous system. The sympathetic nervous system is responsible for the fight or flight response, or also known as the anxiety response. It increases blood pressure, heart rate, and increases the blood flow to our muscles. The parasympathetic nervous system is responsible for the rest and digest response, which is also when our body is in a state of relaxation and calmness. It decreases heart rate, decreases blood pressure, and increases blood flow to the digestive system. Along with the different systems involved, there are also many important neurotransmitters involved. A neurotransmitter is a chemical that sends messages to the brain and influence how we think and act. The three main neurotransmitters are GABA, serotonin, and norepinephrine. GABA, or gamma aminobutyric acid, regulates neuron electric activity. Neuroelectric activity can be defined as interactions between neurons. The body is in a state of calm when the body is in a state of calm when GABA is in process. Panic attacks happen when there is not enough GABA. Too much GABA and too little GABA are both problematic. Too much GABA can cause fatigue and drowsiness, while too little GABA can cause constant anxiety. Without GABA, we would be in constant anxiety, and there would be nothing to control our anxious emotions. Serotonin is a neurotransmitter that is chemically produced by nerve cells. It also sends messages between nerve cells. It is found mostly in the digestive system, platelets, and the brain. It regulates mood, anxiety, and helps with happiness. It induces nausea and diarrhea and helps with the formation of blood clots. Norepinephrine is our third neurotransmitter. It is kept in small amounts in the adrenal tissue and regulates adrenaline levels and is responsible for the fight or flight response. It increases blood pressure, heart rate, glucose levels, and blood flow to specific areas. So, putting all of this together, what first happens is the brain sees or senses an anxiety inducing situation that then triggers the adrenal medulla or part of the adrenal gland to release neurotransmitters, chemicals, and hormones into the bloodstream. Those then go to the ganglion. Ganglion are gaps or junctions where interactions between two neurons or between a neuron and a target gland occur. From there, the ganglion either shut off the systems that are not necessary for survival or give more power and prepare the organs that are necessary for survival. This is done with alpha and beta receptors. Alpha receptors cause smooth muscle to contract, therefore constricting blood flow, while beta receptors cause smooth muscle to relax, therefore allowing more blood flow. Our digestive system is covered in alpha receptors, which is why during the anxiety response, blood is constricted to go there, and as a result, the system shuts off. This is also why we feel butterflies in our stomach when we are anxious. Our leg muscles are coated in beta receptors, and so during the anxiety response, more blood goes to that area. That is also why we shake and feel sweaty when we are anxious. Additionally, like I mentioned before, the parasympathetic nervous system and the sympathetic nervous system work in a balance. So when the sympathetic nervous system increases heart rate and blood pressure, the parasympathetic nervous system will kick in and try to decrease heart rate and blood pressure. That can cause the parasympathetic usually overshoots in this process and can cause a lack of blood supply to the brain, and that can cause syncope, fainting, and lightheadedness. So, as you guys probably know, there are many anxiety medications out there that treat anxiety disorders, and I decided to research a few. So, there are 4 main classes of anxiety medication. SSRIs, or selective serotonin reuptake inhibitors, SNRIs, or serotonin norepinephrine reuptake inhibitors, benzodiazepines, and tricyclic antidepressants. Selective serotonin reuptake inhibitors improve mood by increasing the amount of serotonin in the brain by preventing their reabsorption. The most well-known types are Prozac and Zoloft. Serotonin norepinephrine reuptake inhibitors increases the level of serotonin and norepinephrine in the brain by preventing the reabsorption back into brain cells. The most well-known types are Effector XR and Cymbalta. Benzodiazepines are used for short-term management of anxiety. They promote relaxation, reduce muscular tensions, and help with other physical symptoms of anxiety. They function by increasing GABA reaction. The most well-known types are Xanax and clonazepam. Tricyclic antidepressants are similar to benzodiazepines in their function. They reduce muscular tensions, promote relaxation, and help with other physical symptoms of anxiety. They're usually used over the long-term use of benzodiazepines. The most well-known types are amitriptyline and imipramine. So these anxiety medications, similar to any other medications, have negative side effects. All of the medications that I have talked about can have a variety of negative side effects, specifically benzodiazepines. Benzodiazepines are known to cause dementia in the long run and can also cause problems with tolerance, dependence, and therefore can cause problems with addiction. And the main goal of my project was to figure out how to overcome anxiety without medication. So you guys may or may not have heard of mindfulness and meditation. Mindfulness and meditation is when it helps with calming the mind, and it helps with not worrying about our future actions or our past actions. It has also been shown that when you focus more on calming thoughts, it can rewire your brain to think more that way. This is also known as neuroplasticity. Neuroplasticity is when your brain can change throughout one's life, and this is similar to the idea of muscle memory. And the best example I could come up that is similar to the idea of neuroplasticity is think about the way you cross your arms, but cross them the opposite way. It's going to feel a little bit weird, but if you cross your arms that same way for the next, say, 30 days, it's no longer going to feel weird, and you're going to do that instinctively. This is similar how neuroplasticity works. If you focus and force yourself to think certain thoughts, you will start to instinctively think that way, and that is basically what neuroplasticity is. Along with neuroplasticity and that effect and that related to mindfulness, mindfulness and meditation have also caused a visible effect on the brain. It has been shown to increase the amount of gray matter or cortical thickness in the brain. When gray matter and cortical thickness are increased, those areas become more aware and better concentration. It is increased in the anterior cingulate cortex, the prefrontal cortex. Additionally, the size of the amygdala is also decreased, which I will talk about after I go over the anterior cingulate cortex and the prefrontal cortex. So the anterior cingulate cortex, the main function of that is it monitors external surroundings, helps with cognitive flexibility, and controls the self-regulatory process. When this area gets stronger through meditation, that area becomes more aware and more attentive to our surroundings. The prefrontal cortex is in charge of problem solving, emotion regulation, and planning. It is located in the cerebral cortex that covers the frontal lobe. When this area becomes stronger, we are better able to control our feelings and manage our emotions, and we are able to think more clearly without having to worry about things that aren't really important. The amygdala decreases in size after mindfulness. The amygdala is the main worry center of our brain. It controls the fight or flight response and other anxious emotions. So when it decreases in cell volume, we are less likely to be on edge all the time. So as you can see, the areas in our brain that are responsible for awareness and attentiveness get stronger, while the area that is responsible for our main worrying gets smaller. So as you can see, that this clearly can help with anxiety. So what was hard for me in this project is, well, just coming up here and presenting, because like I mentioned before, I get anxious really easily, and it's really hard for me to present certain presentations. And what was also kind of hard was memorizing the script, because it was a lot of information I had to remember. And specific research areas, because it was really hard to find specifically how exactly anxiety worked. And once I found the information, it was hard for me to understand it. But it's all good. What went well was just putting all the information I found together into the slideshow. That wasn't too bad. And what I also really enjoyed in this project was just researching my topic and learning new things and being able to educate all of you guys about it. So connections to biology. So biology is the study of evolution, life development, and I just said evolution, and also a little bit about the human body. And there are many systems that are involved with the human body, and one of them is the nervous system. And the nervous system is also responsible for anxiety. So in conclusion, mindfulness and meditation are extremely helpful for anxiety, and it both helps with calming the mind and impacts the way we think long term. It's extremely helpful, and there are no negative side effects. So on a more personal note, I get anxious really, really easily, and it's sometimes really hard for me to present presentations like this in front of groups of people, even if the audience are my close friends, family, or classmates. And for those that know me, know that I play piano, and sometimes it's really hard for me to just get up there and play during my recital, because I'm constantly really anxious. And often when I visit a friend or close friend or family's house, I'm asked to play piano, and I can't do it because I'm so anxious, even though I'm just playing for close friends and family. I noticed that this was a problem, and when I heard about the 20% project, I immediately knew that I would want to research this as my topic, so I could learn about what was going on during these situations and how to overcome anxiety. So to conclude my presentation, I decided to include a mindfulness video. Please work.
So no matter what's going on in your life right now, no matter how many thoughts are racing around your mind, no matter how the body's feeling, just take a moment to sit down and take a big, deep breath, breathing in through the nose and out through the mouth. As you breathe in, a sense of taking in fresh air, the lungs expanding. As you breathe out, a sense of letting go of any stress, your body, your mind, just feeling the muscles will soften. And close your eyes if you like. Do one more. Breathing deeply in through the nose and out. And just take a moment before allow it all to come and go. And then just gently unbreathe.
All right, so that's my presentation. Thank you for watching. Oh, sorry, any questions? No? Okay. Oh, yes.
So did you start practicing mindfulness? Did that make this presentation easier?
I will once I have time.
But, I mean, how are some of the ways that you can incorporate that into your busy schedule?
I don't know, just like probably like before you go to bed or before like a test or something, or just before like a class when you have time, just like take time and just like take a deep breath and just realize that everything's gonna be okay. I guess, and that's basically it.
Good. Thank you.
So, hi, I'm Tyler Parada Moliner, and this is my project on how music affects your mood. So raise your hand if you like to listen to music. Okay. So, yeah, I love listening to music, and that's why I wanted to do this project. I listen to music a lot, and I realized that it can affect your mood a lot, and I didn't know exactly how or why, and I wanted to look into that. So the first thing I want to talk about is music in the body and the science behind it. Which are happy chemicals that get released in your brain, which is why you feel happy when you listen to it. Music can also entrain your brain waves, which means that your brain waves will resonate at the same tempo as the music, which can affect how you feel. And other body parts also will sync up to the tempo of the music, and one of these is your heart rate. So your heart rate will match the music tempo, and it'll speed up or slow down. And when it's slow, you'll feel more relaxed. And when it's fast, it can get you through workouts and stuff. So people will have like workout playlists with like up-tempo music that can help them. Another thing it can control is your breathing. And so when your breathing is slow, you feel more calm. And when it's fast, you feel more excited or anxious. So that's another way music can affect how you feel. Music can also trigger your memories. And one example is retaining information. So if you're studying for a test and you're listening to a song, later if you take that test and you're listening to the same song, it can help you recall what you were studying before. And one example I have is also music affecting how you feel. I like to watch Grey's Anatomy, and so there's a song they play a lot in the show, and I'll just play like a few seconds of it here. So that's a song, it's called Chasing Cars. They play it multiple times throughout like the TV series, and every time they play it, it's usually like a sad moment. So now whenever I hear it, I associate it with like sad thoughts because that's what I remember it from. So I also wanted to look into music and movies because I like to watch movies and TV shows a lot, and I noticed that that the songs behind the scenes can affect a lot about how you think of the scenes in the movies, and so movie scores is the music is a soundtrack that plays behind the scenes in movies, and it can have a big impact on the movie or the TV show. And one studio that does this a lot is Pixar. If you watch any of their movies, you'll notice that they have a lot of scoring throughout the back that carries through the whole movie, and it can affect how you feel about it. The best way to show this was to give you an example. So I took a scene from The Lion King and I put it in iMovie and I laid different tracks over it, so you can hear how the different sounds can affect the way that the scene sounds. So here's that. So that was the same. That was the same scene played with the different soundtracks. And you could probably tell that each time the scene played, it seemed a little bit different. And I also want to just compare it to the scene from the actual movie with the music they used. If it'll load, yeah. So you could probably tell that each of those sounded and looked a little bit different, and that's just kind of a way to show how the music can affect how you feel. And any questions? Okay, so thank you.
Hi, I'm Ian Battles, and I'm doing my 20% project on muscle memory. So what is muscle memory? Well, muscle memory is exactly what it sounds like. It's memory for your muscles. As the internet puts it, it's the ability to do an action without giving it any conscious thought. And surprisingly enough, muscle memory is not stored in the muscles, it's stored in the brain, just like normal memory. But unlike normal memory, it is stored in the cerebellum instead of the temporal lobe, which is right about here in the normal brain. And like normal memory, there is short-term. There is short-term and long-term. There's the short-term encoding phase, is when you're trying to learn a new skill and trying something for the first time, also called motor learning. And then there's the long-term, really got it down phase, where you can do it without even thinking about it, like walking and talking. And this long-term muscle memory is stored in stuff called memory cells, which is stored in the cerebellum, which are single cells that adapt and change as you practice and improve your muscle memory. And there's a few different types of muscle memory. There's implicit memory, which is stuff you've been able to do since the day you were born, like breathing. And then there's learned action, which is stuff that you had to consciously learn when you were actually alive, like walking or swinging a sports bat. And in that category, there's two other kinds. There is gross motor and fine motor. Gross motor is like swinging that sports bat, where you're a lot more active and a lot less precise, where you're using a lot of different parts of your body. And fine motor is manipulating a small tool, like painting or handwriting. Why do we have muscle memory? Well, the answer is pretty obvious, because we really can't do all the things that we do while thinking about all of them. Like right now, most of you are probably breathing, but you're not even thinking about it. Whereas if you didn't have muscle memory, you would have to think about breathing or walking or talking all at the same time, which is basically impossible. So now to jump back to my handwriting, which is pretty bad. This is from English homework a few months ago. It's very awful. And for the longest time, I was perceived as stupid because of my handwriting, from friends, teachers, and probably parents, because only an idiot would write like that, right? And that's why I did it for my 20% project, is because I never really had the determination to improve my handwriting. But with a 20% project, I can get two birds stoned at once and improve my handwriting, while at the same time educating people about muscle memory and its significance. So speaking of improving, there's two different parts of improving one's handwriting. There's general motor skills and actual practice. And general motor skills is basically the shakiness of your hands. And as Forrest, a classmate who's probably presenting in the other room right now, put it, I have arthritis hands. And so what that basically means is my hands are very, very shaky. So when I went about improving my general motor skills, I tried a few things. Basically manipulating small objects, like folding and unfolding pieces of paper, opening and closing letters, and playing video games. But the more important part was practice. Just a lot of practice. Just do the same thing over and over again until it goes out of that short-term encoding phase and gets stored as memory cells in the long-term phase. And I've called these, surprisingly enough, practice sheets. Now there's a few important things to know about these practice sheets. Even though I only showed letter practice sheets on the previous page, it's also important to practice words, because if you don't practice words, then you're not actually improving your general handwriting, you're just improving individual letter writing. And you have to really train your body into knowing that this is what your handwriting is supposed to look like, and not just individual letters. And so when you're doing one with words, you have to make sure that you know the content of whatever you're writing, whether that be a common phrase like the quick brown fox jumped over the lazy dog, or a song. I did All-Star like 10 to 15 times because it's the only song I know. I just kept on writing that over and over again. And this idea of repetition is used in physical therapy. Let's raise a hypothetical scenario. Let's say you get in a car crash and a piece of your arm was severed off and you have to use some sort of prosthetic. Well, in physical therapy, they would teach you how to properly use your new prosthetic by repetition and teaching you how to use it. Another hypothetical example is if you got in a car crash and for some reason or another your body forgets how to walk, which can happen. Then they would try over and over again to get you to walk with small steps until you can get out and walk out of the room. So did it work? Did all of this training and muscle memory practice actually improve my handwriting? Short answer, yes, it actually did. So I first noticed it about 3 weeks in when I was doing some English homework, and I realized that my handwriting was legible. Not neat by any stretch of the imagination, but it was most certainly legible. Now compare this to the previous homework I was showing you before. It's pretty low quality resolution, so you can't see it very well. But you can definitely see a clear distinction from normal human being handwriting into whatever that is. So now to jump into my reflection. I found pretty early on that it's important to stay determined because it's really, really, really boring to write these practice sheets. So it was really easy to just give up and do something else. But if I did that continuously, I wouldn't really be practicing my handwriting. So if I did it again, I would make sure that I stay determined and stay focused the whole time through to guarantee that I did that. And in the short term, also just focus because, once again, it's really easy to get sidetracked when you're writing the same thing 8 times. And another thing that I learned is write quickly. When I started these practice sheets, I made sure that every single line was just exactly perfect and nothing was out of place. But in reality, when I did that, I wasn't really practicing my handwriting. I was practicing like a really careful signature or something because I wasn't actually practicing what my normal handwriting would look like. So if you're going to do this at home, and I know none of you are even going to try, you might want to write quickly so that it's actually your normal handwriting and you're practicing what you would normally write like. And now to end the presentation, I would like to ask a question that all of you are thinking right now. Is it worth it? Is it worth it to actually do these practice sheets over and over again until you get better? Because that's a lot of time spent or wasted, wherever way you look at it. And this can be applied to any skill in general when you're practicing muscle memory, like a sport or an instrument. You must decide for yourself if it's something that you really want to spend that amount of time working on and really dedicate all of your time to. That's the end. Thank you. Questions? Oh yeah, definitely. As you saw on the reflection slide, it was a dramatic improvement. And I had to do something for my 20% project, so.
Ian, how is your handwriting, what I call handwriting, cursive?
Oh, I have no idea how to write cursive.
Really? Okay.
No clue. When everyone else was learning cursive, I was still learning how to actually write, so.
Does muscle memory work the same between fine motor skills and gross motor skills, or does it happen in its own different way?
Well, the whole motor skills in general with the shakiness of the hands is a lot less relevant when you're doing gross motor than it is in fine motor, but the general repetition is definitely the same. Is that it? Cool. Oh. Thank you. You too.
I don't need audio now. Oh no, it's here. Oh, I think I gotta grab these. Give me 1 second. Am I on the right slide, actually? I think I'm on the right slide. Give me 1 second. There, all right. Right, well, hi everyone, I'm Devin Perry, and for my 20% project, I decided to do something a little different and explore our universe's planets, and specifically, if life could be supported on any of them that we know exist right now. So I'll give a little introduction and why I chose this project. So, well, mainly why I chose this project. I decided to do this because the universe and space is something that's fascinated me for years. I've always mused the idea of life existing on other planets, and so I decided that
I would educate myself, and then I would share it with all of you that are here tonight. And that's, yeah. So first off, I think I need to first talk about what a planet needs in order to support life. And so mainly, I think really one needs to consider what does an organism need in order to survive. And one of the main things you'll think of is water. And so by definition, the habitable zone is any place that, in accordance to the amount of solar radiation the planet receives and how far it is from its sun, that the planet will be able to have water on its surface. And so that's, yeah, it's known as the habitable zone, as I previously said. Now, I did mention that it depends on how far it is from the sun, and depending on the sun's size, as you can see, the habitable zone can vary. For a hotter star, that habitable zone would extend very, very far out, and for a cooler star, like a red dwarf star, which is a much older and smaller star, you would have a very small habitable zone. And so right here, this is just 20 planets that have been discovered that are only about double the size of Earth. And as you will see, that's a very, very small amount. And if you want to see the total amount of exoplanets that have been discovered, that's all of these right here that actually could support life that have been discovered. And these are also only the confirmed ones. There are many other candidates that have not been confirmed yet. Now I decided that now you know about that, I'm going to go over some planets that actually could support life. So, the first one is known as Ross 128b. It orbits a very quiet red dwarf star, and when I say quiet, I mean it does not emit, the sun does not emit many flares. It's 11 light years from Earth, but in 79,000 years, which may seem like a long time, but in the large scale of things, it's pretty small, it's expected to become our stellar neighbor. Compared to Earth, it receives slightly more radiation, and it's much closer. And it's expected that because of this, the temperature of this planet is much lower. And its conditions are similar to Earth's, and that makes it one of the top candidates to actually either support life or have people migrate to this planet and live on it. So the second one is called Kepler 22b. And it was the first one to be found by the Kepler Space Telescope back in 2011, and it was announced with 54 other planets. It's estimated to have an average temperature of about 72 degrees and a diameter 2 to 4 times bigger than that of Earth. The parent star is expected to be a G-type star, which is also the same type of star our sun is, but it's a much smaller and colder one. And it's very hard to discern by any current telescope, and it's 600 light years away, so that is self-explanatory why it's hard to tell. And with more technology advances, we'll be able to probably discern this better and tell if it will be able to be habitable. The third one is HD 85512b. I'm sorry, it's D. That's a mistake. And along with 6 other planets, this super-Earth resides in a planetary system that is 44 light years away from Earth. Its location is directly at the edge of its sun's habitable zone, and that has captured the attention of many astronomers that think it'll be a good candidate for life. It's, I already mentioned, it's 35 light years away from Earth, and it's the lowest mass planet found by a method of radical velocity that potentially lies in the habitable zone of its star, and future research shall also determine if it does have water. Like many of these you'll see. Only have a few more though. Next one is Gliese 581d. It orbits a red dwarf star that lies 20 light years away from Earth, and it's located right in the middle of the habitable zone. Also, this trait also causes it to receive much attention. It's a rocky planet, and it's similar to our moon. One side is completely in darkness all the time, and the other is always covered in sunlight from its star. And after extensive study, it was proven that both sides, if it had a thickened carbon dioxide atmosphere, they both could support water, despite one side, being in darkness all the time. And it's still on the fence if it is indeed habitable, because sometimes these planets, they aren't always accurate with discoveries, but more work will be conducted, and that will be able to be discerned. And so the last two, these two are both in the same exact system. The first one's Tau Ceti E. It resides 11.9 light years away from Earth and a 5-planet system, along with its neighbor, Tau Ceti F. And they're both in the habitable zone. However, the other three, they appear to vary widely from Earth. These two along with the other three, I mean. They are much larger, and they seem to have different mineral makeups. And after more extended examination, Tau Ceti E, the last one, appears to possibly lie outside of the habitable zone, and the second one, this one, Tau Ceti F, seems to be a much more promising candidate to support life. And so in conclusion, and some of just my personal thoughts, could life exist on another planet? We don't know, but it definitely could, and by some of these, and especially with some of the earlier examples, such as Ross 128b, it seems that there is a great chance that there could be another planet that supports life. And so a little reflection. First of all, what worked for me, I enjoyed doing this research, definitely, but I wish I had some more, and it was kind of hard to find some considering they don't know a lot about all these planets and stuff, and it was very different from a lot of others where people talked about the brain, and it was hard to make a biological collection. But of course, there are a lot of things that factor into this, such as an atmosphere that could indeed support a life form such as us, or possibly like a different life form that we haven't seen on Earth or anything like that. And so, thank you. Any questions from anyone? Yep.
I noticed at the end of a lot of names for the planets, there was a letter. What does that letter mean?
Well, I'll go back a few. When you see, for this one, Tau Ceti, that is technically the name of the system, or sometimes the name of the star, and F is what they consider the planet. And the last one, E, is in the same system. The E clarifies that it's a different planet. And I think the other three are A, B, and C. I don't have a D, it just isn't there, I guess. Yes?
You got mass on there, particularly a range of multiplier times Earth. Can you estimate the gravity for each of those planets based upon the mass? Or would you be able to?
I would be able to. Now I couldn't give you an answer because I didn't personally look into the gravity, and I don't think there's a lot of information gathered on gravity of these planets, just estimated by what they think the mass is. I'm sure there is, but just through my general research, I didn't find anything like that.
Could you give an estimate of how a change in that gravity would affect life? Say, if we had a change of gravity on Earth to emulate or to model what might happen on one of these other stars, what might be some changes that you'd see?
I mean, obviously, we've been on the moon, and there are changes of gravity there where you're not as bound to Earth, but in an opposite scenario, you might be more bound to whatever that planet, or not more bound in a sense, that's a bad word for it, but more constricted in what you could really do. And so you might not have as much an enjoyable lifestyle as if we did on Earth, if you were kind of just more confined in your actions. On the other end, if you were on a planet like the moon with very low gravity where you are kind of free to bounce around and stuff like that, you might be a bit more enjoyable lifestyle, and that might be more, I don't know, enjoyable opportunity. Again, something I didn't really look into that much, but just I guess for that part.
Were there other components to these stars that you mentioned water, right?
Yeah.
What might be some other components that you think might allow for life to survive?
Components of the stars, you mean? Aside from just, you mean size, because obviously the size plays into it greatly, and there's solar radiation, and that combined with, of course, the size determines whether or not water can exist on there. I also didn't find a ton on really solar radiation, but that'd be something if I were to research more on that, I'd probably look at that and determine how that would affect this process more.
Could you estimate, could it be estimated what the atmosphere might be like on some of these stars?
They know some of them. For example, I believe it was this one, Gliese 581d. They didn't estimate it, but I mean, they said it could have water as long as it had a thick carbon dioxide atmosphere. They couldn't necessarily tell. A lot of these planets are really far away. One of them was I think, well, this one, Keeper 22b, is barely discernible by telescope, and so obviously they really can't tell with this one. Some of the closer ones, some of them 11 light years away, those they might be able to tell, but also not a lot of information on that. Anything else? All right. Thank you. Oh, shoot, yeah. Good luck, Zachary. Holy crap, that was horrible. That was so bad. Thank you. Oh, Zach. You might require this microphone.
What does it amplify?
It's for this, because there's no speakers here, of course, but it's so that they can hear it if they're watching the live stream.
How do I pull up? So I script a bit over there. I was wondering how I would pull up. I think you did a similar thing the other day. You pulled up that on one desktop, and it showed it. I was able to examine presenter mode or something.
You know, you're 14%.
Oh no. Oh, there's an outlet down here actually. Any chargers?
My charger's being used.
Okay.
In the other room.
Wait, did this toggle? I apologize. Does anyone possess a charger that I can take?
I got you.
Thank you, DP. Actually, you know what?
What are you doing?
Providing me with a Kit Kat.
Oh, thank you.
Ah.
What if I trade like the extra bonus points? That's why I have 2 chargers.
Do you mind?
Would you like the good charger or the slightly older charger? You can have the good charger just because you give me it.
No preference.
Here.
Thank you, my friend. You know what? Take a brown one and a red one.
Oh, thank you.
Decentralizing science, the development of a cure for cervical cancer. Salutations and thanks. My name is Zachary Switey, and as evinced by my title, for my 20% project, I attempted to develop an original biotechnological treatment for cervical cancer. And in doing so, I realized something imperative, an imperative issue with the scientific community, which I shall mention further along in my presentation. I was inspired to do this project on account of the fact that biotech that provides a suitable treatment option for cervical cancer is relatively unexplored, is relatively undeveloped, and also on account of the reality that cervical cancer is such a severe disease and that developing a cure is an urgent matter. In this presentation, I shall first discuss the biotechnology that I designed base pair by base pair, 20,000 base pairs. Lengthy thing. A base pair, for reference, is like an individual letter of DNA, an A, a C, a T, or a G, one of those individual bases that encodes DNA. So, and I shall subsequently notify you of the issue that I located within the scientific community. Oh, actually, I apologize. The objective for my project was, of course, curing cervical cancer. So I separated this presentation into 2 sections. One, again, the original biotechnological approach to selective apoptosis induction in cervical cancer cells. That is a bit of a mouthful, so let us deconstruct that. So an original biotechnological approach, obviously an approach and a treatment proposal that involves biotechnology, which is essentially technology that integrates aspects of biology and also selective apoptosis induction. So apoptosis is essentially programmed cell death. So apoptosis induction would be the act of causing apoptosis, causing cell death. Selective apoptosis induction in cervical cancer cells would therefore translate to killing only cervical cancer cells, cells that are cancerous, cells that are harmful to the body. I separated this section into two subsections. One, why I attempted to cure cervical cancer, and the second, how I did it. So first, I shall commence with the more comprehensible of the two, the more obvious, and provide you with a preliminary characterization of cervical cancer's effects and mechanisms. So now I shall provide you with a bit of a deceptively odd fact. According to the CDC, the Center for Disease Control, in 2014, 12,578 women were diagnosed with cervical cancer, and 4,115 died from cervical cancer. Now, that is nearly a 1/3 ratio. That is substantial. That is a substantial death rate. There we are. All right. And it may seem surprising when considering that HPV, human papillomavirus, causes nearly all cases of cervical cancer, and HPV preventive measures for HPV have become more ubiquitous in recent years. However, when we consider developing nations, uncultivated regions, rural areas that may not possess access to such preventive measures, the fact becomes a bit less surprising. Indeed, 80% of cervical cancer cases actually occur in undeveloped nations. And we cannot expect these nations to be able to access such treatments for HPV and cervical cancer. And when we... apologies. And when we analyze this inaccessibility with the with the inadequacies of current cervical cancer treatments, the failings, and also the survival rates of cervical cancer, which can reach levels as diminutive as 15 to 16% in most advanced stages. It really evinces the severity of cervical cancer. So with some of the treatments, such as surgeries, hysterectomies, they cause infertility, these severe side effects, and yet possess suboptimal success rates. With radiation, another example, radiation causes severe side effects such as skin damage and cancer recurrence as well, and yet it possesses only a 50% success rate in the most treatable of cervical cancer stages. So in summary, these current treatments are unsuitable when considering the implications of recently developed biotechnologies, as a quote by me. We require a cure, my comrades. So my proposal, second subsection of the first section, utilizing biotechnology that I engineered to kill cervical cancer cells. So with HPV, how it causes cervical cancer is through its E6 and E7 oncoproteins. Now, these boys are right here. What they do is they are produced by the HPV genome, and they serve to degrade the P53 tumor suppressors and retinoblastoma proteins that regulate cells. So they prevent cells from becoming cancerous in regular somatic cells. So what these do is they destabilize those prevention mechanisms and cause tumor development in cells. Now of course, these seem to be unenjoyable. They cause cervical cancer. However, I think that we can actually utilize these to our advantage when considering synthetic biological circuits. So with synthetic biological circuits, they are essentially these plasmids, these circular pieces of DNA that function in a manner that is very much similar to electronic circuit. With these circuits, they take the input of the circuit. They recognize the presence of something in a cell. They recognize a genetic structure, a protein, a molecule, anything with a DNA sequence. And in response to that, they output another protein, something with a DNA sequence as well. here's an example actually of one. So with these, it takes these inputs, these various proteins and such, and in response to these, it performs all of these functions, which eventually results in the output of RFP protein. So I thought that we could utilize this to recognize recognize the presence of E6 or E7 oncoproteins in a cell, and if the cell possesses the E6 or E7 oncoproteins, induce apoptosis. Which, does anyone recall what apoptosis is? If I do, Kit Kat, programmed cell death. You can take that as well, DP. No. So they cause selective apoptosis. They kill the cancer cells. They kill cells that are cancerous, which would eventually constitute a cervical cancer cure. So it becomes a bit more complex, though. This task becomes a bit more complex when actually figuring how to cause the apoptosis. Cancer cells are able to evade apoptosis. They possess various mechanisms such as multiple nuclei that prevent apoptosis from occurring, and as aforementioned, they they degrade certain mechanisms that are in the cell to regulate the cell. So essentially what I thought of was simulating natural apoptosis. All of these protein boys, they are apoptosis inducers. So what they do essentially, Bax, BAD, BID, caspase 3, PUMA, they all either cause apoptosis or activate apoptosis causers. Or in the case of PUMA, they deactivate apoptosis inhibitors. So what PUMA does actually is it binds to certain proteins that prevent apoptosis from occurring. What Bax and BID do in caspase 3, they actually initiate the apoptosis. Caspase 3 pierces the mitochondrial membrane. The second component of that is only one component though of actually causing apoptosis. The second component would be doing would be inhibiting the cancer cell mechanisms that are able, the aforementioned cancer cell mechanisms that are able to decrease the efficacy of those proteins. Some of these would be the BCL2 genes, BCLX, all of these in the BCL family, and of course the MCL1. These are all genes that produce certain molecules in a cancer cell that serve to deactivate those pro-apoptotic molecules and such. They would essentially prevent the cell from experiencing death. So what I thought of to inhibit this was to develop an intracellular CRISPR system. A CRISPR system, CRISPR is an acronym for Clustered Regularly Interspaced Short Palindromic Repeats, a lengthy acronym. But basically what it does is it essentially, a CRISPR system comprises sgRNAs, which are these guide particles, these pieces of genetic code, and it also comprises a Cas9 enzyme, which is a protein. So what the sgRNAs do is they guide the Cas9 enzyme to a specific location on a gene in the DNA of a cell, and the Cas9 enzyme, it actually cuts out segments of the DNA to disrupt the gene, such that it is dysfunctional. So again, it became this is enjoyable, but when I was actually designing it, it became a bit more complex. Eventually, though, I resolved to, in order to disrupt all of those 5 cancer genes, I utilized a principle that is referred to as multiplex expression, which is essentially the ability of Cas9 to be guided by 5 or more, multiple separate sgRNAs and still perform its functions. So what I did is I created an sgRNA that corresponded to each of those 5 genes, each of those anti-cancer, anti-apoptosis genes, and as to guide the Cas9 protein to those genes such that it could cut segments of DNA from them and disrupt the genes. When I actually was synthesizing the circuit, when I was actually designing the base pair, in order to allow the circuit to function as a biosensor for E6 or E6 and E7 to actually recognize the molecules. I took the input as the A3B promoter, which is activated by E6 and E7. I took the outputs as all of those things, those BACs, intracellular CRISPR system, all of those things. So what I did in order to actually spit out that DNA sequence, though, is I programmed it into a combinatorial design layout program that essentially would, so I programmed all of this code in there, and it calculated, this is the code for a circuit, and it calculated the various layouts of the circuit and selected one based upon the possible toxicities of the circuit, the ability of the circuit to function correctly. So again, with this, this is the input one, this is the A3B promoter, and it corresponds with the 0 here. And all of these outputs are, again, those molecules, and the intracellular CRISPR system. So when the input is inactive, when it is 0, all of these molecules were also inactive. This would allow selective apoptosis induction. So in a healthy cell, when the E6 and E7 are not present, none of those proteins are produced. The cell is not killed. However, in an unhealthy cell, when this is a 1, when the E6 and E7 are present and activate the A3B promoter, all of those things are produced and eventually kill the cell. The tactic here is essentially to overload the cell with signals to commit suicide. No. This is a complete diagram of the circuit. All of these outputs, as aforementioned, those are the 5 sgRNAs, the Cas9, all of those things, all of that pro-apoptosis, and of course the A3B promoter. Whoa, is that not even loading? All right. So originally, there was supposed to be. There it is. There it is. All right. So this is one-fourth or one-third of the complete sequence. 20,000 base pairs. It actually, I become physically ill when I examine. It is so sickening. This again, 1/3 size 6 font times New Roman, my friend, single spaced. Each of these 20,000 base pairs, each base pair is just a single TGA, one of those things. It was an unenjoyable process creating this. But the combinatorial design program actually ameliorated some of the difficulties of it, though. So now that I possess the circuit, now that I designed that completely, it was time to develop a delivery mechanism such that the circuit could actually enter the cervical cancer cells. So what I selected was, since the circuit is a plasmid, as aforementioned, a plasmid. Does anyone recall what the definition of a plasmid is? Circular piece of DNA. All right. What was that? Oh, you did? Well done. Circular piece of DNA. And a plasmid is customarily cloned into what is referred to as a vector. A vector is the vessel in which that contains the plasmid, that delivers the plasmid to a cell, that allows the cell to intercept and consume it, to transfer it to its DNA. So for a vector, I selected a virus, actually, a lentivirus, such that all of the cells in the cervical cancer, all of the cervical cancer cells would be infected and contain the synthetic biological circuit, such that they could be killed. So in summary, I designed a synthetic biological circuit that is capable of selectively inducing apoptosis in cervical cancer cells. Now, section 2. All right, this is the issue that I found with the scientific community. So, when I was attempting to actually produce the circuit, so I originally intended to take it out of my pocket or something, like cured cancer or do a research paper or something. I am unsure. So for this presentation, so in pursuit of that, I contacted some firms. For instance, Adgene is a nonprofit in Cambridge, Massachusetts that specializes in CRISPR system and plasmid development as well. They referred me to this organization, Thermo Fisher. So I first discussed services with Thermo Fisher. I emailed them the complete sequence in hopes of acquiring a quote from them. The quote that they provided me with, of course, was $6,000 US, which infuriated me. I rose from the ground in just complete anger. So I found that I was unable to produce my circuit with them. I contacted some of the other firms that they referred me to. One was Adam. I telephoned Adam. They never responded with an email. And the second was Origin, and I don't even know what is occurring with that. So even if I acquired the circuit, even if they produced it for me, I would be unable to do research with it, since Worcester Academy cannot culture mammalian cells. They cannot produce the cells that are required for me to place the circuit in, and also I would require HeLa cells, which are $500. Those are cervical cancer cells that produce immortally unless they are killed. And also, they cannot provide me with $6,000 US to produce the circuit. This presents. So that is an issue, all right. Still, I shall not allow it to deter me. I intend to pursue production of the circuit by perhaps acquiring a position at a research laboratory that is capable of DNA synthesis and can culture these HeLa cells. Those are the HeLa cells right there. I actually intend to enter my circuit in a science fair that I'm doing in March of my sophomore year as well. But this is reflection. This is what the issue is in summary. Essentially, science is not decentralized. It has not yet been liberated from those ivory tower academia. It does not provide everyone with an opportunity. In order to cure cancer, I think that we must provide everyone with an opportunity. Now, some companies have recognized this, and they are in the process of developing technologies that shall allow everyone to attempt to cure cancer, such as Odin Labs. They actually offer CRISPR kits to construct the systems. I purchased one of their CRISPR kits. It is in my refrigerator. The instructions were so poorly done. They were absolute nonsense. There is E. coli in my refrigerator. And also another one, Cambrian Genomics. They were attempting to develop a 3D printer that is capable of printing all of those bases, such that I could actually do that in the Worcester Academy library or something at my house. I could print that entire 20,000 base sequence. However, the CEO committed suicide, so that is essentially no. Whoa. Laughing at that? So that's essentially no more anyway. But anyway, this is the quote that I shall utilize to summarize this. You could say that right now we are discovering all of the parts of a Boeing 747 and meticulously laying them out on the floor of a hangar. Still, the plane does not fly yet. This is, however, the next generation of scientists, of young scientists, is figuring out the circuits into which the parts fit. This was a quote concerning when, this was James Fallows in response to when will we cure cancer. I think that curing cancer can be reduced to a simple numbers game. Thank you. You know what? Just provide everyone with some of these. Please provide me with 4s on my rubric. Consider this a bribe. Exactly. Decentralizing candy production. Thank you. Say when. When. Oh, yes, questions. Any questions here? Yes?
How do you come up with that circuit you were talking about, the 20,000?
Base pairs?
How do you come up with that?
Wait, how so? How did I think of doing that? How did I?
How do you design that? You actually.
Oh yeah, yeah.
You talked about how you exactly. It sounds like you're targeting the C6 and C7, and you based on all this and looking at what induced the apoptosis. But how do you exactly say, oh, this is the sequence?
Oh, so essentially what I did, this took months of grunt work, just finding all of those proteins, all of those gRNAs, the Cas9. I found the exact DNA sequences for all of those. Cas9 is 4,000 bases. I was required to translate all of that into DNA sequences. So what I did with those DNA sequences, I utilized the combinatorial design program that I mentioned, and essentially I placed them in there, and it sort of calculated them for me, and it outputted the most efficient way. It is not so. It is relatively simple to concatenate all of those sequences into a circuit. However, what the main function of the design program was to insert these bacterial logic gates, which essentially are the things that control a circuit. Think of it as somewhere in an electronic circuit, for instance. There are those gates, AND gate, OR gate, that determine what the output is, the output's response to the input, what is outputted. So essentially, it inserted DNA sequences for those into my into the collection of sequences that I collected. Thank you. Owen.
So for the virus that you chose to bring the sequence in,
Mhm.
Do you know any more about that virus? What would it do inside the body?
Oh, sure. So essentially, lentivirus it is capable of carrying genetic material in high volumes, and it is also quite potent. It infects a substantial quantity of cells. So what I think it would do is that is more or less what I'm familiar with it about. So what I think it would do is it would infect all of the cells in a particular region, and I think it would do it well, and transmit what it contains, the plasmid, into the cells, the region where the DNA is kept, such that the DNA could function. It is actually commonly used in similar projects. No, not exactly. It's just more or less a sort of hollow thing. It's a placeholder, for instance, I suppose. Yes? To manifest a quality or feeling or something is close to the dictionary definition, from what I recall. Any other questions? Dr. Crows?
Why did you choose to put all of these genes in a single plasmid?
I don't know. I think that is just what a synthetic biological circuit is, I suppose. That is how it functions, I think. It is regulated by those bacterial logic gates, and those control in a single plasmid, and they control the outputs of the various genes.
Would you have problems then putting that big plasmid into, say, even a bacteria to try and produce it in mass?
I mean,
or even a cell?
possibly. I'm not exactly certain. I would have to get back to you on that.
So if you did have problems, how could you end up troubleshooting them?
Oh, I think allowing the quantity of those pro-apoptotic molecules to be more precise, I could likely condense it into the bare minimum. I think with that, I just utilized as many as possible. However, I think I could condense it into a bare minimum that would be functional. Oh, well, Bax, Bad, Bid, Puma, Noxa, and the intracellular CRISPR system. Can I take two? All right, I suppose Bax, or actually, I would choose one protein that activates it, possibly a BH3 or something. BH3, it was on there, and one effector protein, possibly caspase 3 or Bax, either one of those, and I think they would be able to, since the circuit produces them in high volumes, I think they would be able to integrate nicely. I think they would cause apoptosis. Okay.
feedback forms. So if you'd like, just leave them on the desk. Thank you. And thank you very much. You are all.
Oh, thank you for this.
Can I take a Kit Kat?
Of course.